Hello my dear students, we are going to solve this sum today. The sum says that 40 lamps, each of resistance 8 ohms, are connected in a series to a 240 volt supply in order to decorate a tree. So first part they have asked calculate the current in each lamp. So in each lamp they have asked. So here you can see 40 lamps resistance in series. Series means what? It is being shared. 40 lamps are sharing this 240 volt amongst themselves. So we have to use unitary method to find out. So for unitary method, how we can find out? Like 40 lamps, so they are sharing 240 volt of supply potential difference. So one lamp will share how much? So X. So X into 40 equals to 240 into 1. So X equals to 240 upon 40. 4 4 is 6 is 24. So here 6. So here we got 6 volt. So 6 volt. Each lamp is sharing 6 volt because each volt they have asked the current for each lamp. So we found for voltage for each lamp now. Potential difference. So we will now calculate the current. How we can calculate the current? We will use Ohm's law. So Ohm's law states that here I will explain you here Ohm's law. So Ohm's law, at a constant temperature the current flows through the conductor is directly proportional to the potential difference. So this is Ohm's law. Voltage is directly proportional to the current. As you can see here voltage is 1.5, current is 5 ampere. You can see voltage has become doubled, 3 volt. Then this also current, it was 5, it has become double, 5 to the 10. Now here you can see 4.5 here. Voltage we have increased to 4.5. So it has become 15 ampere. So you can see how it is. We are multiplying this by 1.5. So here you can see 6 volt. So here it has become increased 20. So you can see 5 1 5, 5 2 7, 5 3 15, 5 4 20. Here also you can see 1.5. Double the 3, 2 za. So here 3 za, 4 za. So you can see like that it is increasing. So we can say voltage is directly proportional to the current. This is Ohm's law for any resistance. So here R is constant. Here you can see R because proportionality sign we have to remove. So when we are removing this proportionality sign, direct proportional or inversely proportional, so we have to put one constant. So this is the constant and that constant is R. So we will use this formula to solve this question. So here we will use V equals to IR. So as you can see here, V equals to IR. So we found now here this voltage also we know, and here we know this ohms, resistance in ohms. So we know this resistance here and we know voltage here 6 ohms. So we can substitute these values here. So here instead of R I will write below R 8.0 and I we want to find out, and voltage is 6 volt. So 6 volt. So now I is equals to 6 upon 8. So it will come as 0.75 ampere. So here we got the current as 0.75 ampere. So now they have asked one more in the second part of the question, the power dissipated in each lamp. So we will use that formula for power is power equals to voltage into current. So here we will use our whatever the contents are there. Power equals to V into I. So how we got this derivation power? How power? So here we will go through this. How we got this? So here power is defined as work done per unit time. So you can see per unit time. So in this way power is defined here. So power is defined as work done in a unit time, 1 second. How much work is done in 1 second? So this is normal power. We are talking about electric power. So electric power is the electrical work done per unit time. means how much work is done. See here. So here how much work is done in 1 second. So unit of power is watt. So you can see unit of power is watt, 1 watt. So you can see 1 watt equals to 1 joule of work done in 1 second. So you can see, so here definition of watt: when an electrical appliance consumes electrical energy at the rate of 1 joule per second, its power is said to be 1 watt. So you can see here 1 joule per second. If it is consuming that much work, energy, so the power is said to be 1 watt. So we will use this formula. So work upon time. So from this we have derived another formula: P equals to power equals to V into I. So I will show you how to derive that. This is how the power formula has been derived. So power equals to work upon time, as you can see here. So work equals to I square RT. So this is actually Joule's law of heating effect. From there we got it. So we will substitute work with this I square RT, and we got this I square R. T will get cancelled here. So IR. So V equals to IR. So equals to, you can see, but P equals to VI. So we can write here as P equals to V into I. So in this way we have derived this formula, power formula. So let's go back to the question. Actually this derivation is not there for IGCSE. So just for information I have given you. So power equals to V into I. So let's substitute the values here. So here we got here voltage. So current is I, we got here as 0.75 ampere. So I is 0.75 ampere. So voltage. So voltage here 6 volt. So here 6 volt is there. We got here na 6 volt this. So 6 volt, 6 into 0.75. So power. So 6 into 0.75. So we will be getting 4.5 watt. So unit of power is watt, that I have shown you here in previous slide. So here when electrical appliance consumes electrical energy at a rate of 1 joule per second, its power is said to be 1 watt. So we got this answer for our power. Now we will do the second part of the question. So second part of the question is tricky. So here the lamp is designed to fail short. If the filament fail short means, see this, all these lamps are arranged actually put in a series. So they are actually arranged in a series. So if one lamp will fail, others will stop working because it is in one line. But the thing is that they have put one thing, that is fail short. So what it will do, if one of the lamp fails, then it will not affect other lamps. But in case of parallel, if one fails, then it doesn't make any difference. But here they, instead of making it parallel in series, they have put in the series condition only. But they have used this fail short concept here. So they have designed so that if one lamp actually doesn't work or gets fused, then also other lamp will work. It will not affect the other lamp. While generally in series, what happens, if any of the lamp filament goes off, the other lamp will also stop working. So here it is designed in a fail short manner. If a filament fails, the lamp shorts so that it has no resistance. So that resistance will, because of this fail short concept, the resistance will become zero. So the other bulb will grow. Other bulb will not stop glowing. Okay, will go glowing. Okay, so other bulbs will glow as it was glowing. The other lamps continue to light and the current increases. The lamp are connected to the fuse that blows when the current rises above 0.9 ampere. So fuse is actually, it contains an alloy. When like certain amount of current flows, so because when current flows, heat also increases. So like here 0.9 ampere of current will flow, so that much amount of heat will flow and that alloy will melt at that temperature. So whole of the system will, that current flow will stop. So here they have applied one fuse. At this current resistance of each lamp is 5% greater than the normal working resistance. Calculate the maximum number of lamp that can fail before the fuse blows. So let's solve this question. So here first we have to find resistance of the lamp. So first part we will do is what? Resistance of the lamp we will find out. Resistance of the lamp. So here they have written here 5% greater than normal working resistance. So 5% means 5 upon 100. Normal working resistance here, let's see in the question here, 8 ohms. Normal working resistance is 8 ohms. So here, so 5%, 8 ohms. So here they have written here 5% normal working resistance greater than the normal 5% greater than the normal working resistance. So plus 8. So here it will come as 8.4 ohms. So resistance of the lamp we found out. Now we are going to find out second thing, like total resistance. So second, total resistance. Total resistance. So for finding total resistance, here we know voltage is how much. So here voltage is 240. So total voltage is 240 here in the question you can see. So we will write here 240 volt. And current, total current, let's see total current here. So total current here, 40 lamps here. So they have given here lamp is connected to fuse and blows and current rises above 0.9 ampere. So 0.9 ampere it can actually withstand this much current. So total resistance is this much. So current is equals to 0.9 ampere. So volt and ampere we found out. So we can find out resistance easily using the formula V equals to Ri, Ohm's law. So R equals to V upon I. So 240 upon 0.9. So here so we will get 266.67 ohms. So we got this. Now we will divide these two things. So number of lamps before actually fuse is blown, we will get this answer. Maximum number of lamps that can fail before the fuse is blown. So this will be what? So number of lamps which will fail is equals to resistance total, this total resistance, okay, upon resistance of lamp. So resistance of LAMP lamp. So resistance total is this 266.67 upon resistance of lamp is 8.4 ohms. So we will be getting the answer as 31.7, which is equivalent to 32. So the answer, the maximum number of lamp that can fail before the fuse is blown is 32. So in this way we can solve this question. Thanks for watching. Don't forget to subscribe.